I'm saying, slow me down. Can we do that? I'll just kind of go along and everybody say, slow down. All right? So merge sort. What I'm suggesting you do is you just worry about your own job, your own stack frame as it is, which is, so you're given some input instance. All right, there it is. That's you. You're the little yellow guy, and you're given some input instance. And you're ensured that your that your precondition is true. And the precondition in this case is you've been given a bunch of numbers. So it's not that exciting of a precondition, but there you have it, right? And what's your job? Your job is to produce the output, and of course, it must meet the postcondition, right? And what is our technique in between? People call it divide and conquer, and it's basically we're going to get help from our friends. All right, and so you can have as many friends as you want, and what you can give your friend, each friend you give a subinstance. And so here's a little subinstance. It's a set of numbers, and what needs to be true about this subinstance is that it has to meet the precondition, and because it has to be an instance to the same problem, right? So it's given an input that meets the precondition of your same problem. Whatever precondition you have, your friend has as well. And the other requirement is that you have to have some measure of the size of your input, and your measure can be whatever you want. And according to that measure, your friend's input is smaller than your own input. All right? Does that make sense? And then what you do is you trust them to give you the solution for the instance that you gave them. All right? And as I said, how do they do it? How do they get their answer? Well, let's just assume it's by magic, by trusting your friends, not micromanaging them. All right? It was funny, the very first term I ever taught here, I was teaching recursion along with a real serious guy, and he and I were talking about this, and I was telling him about friends and magic. And then it turns out that when he went to class, he did say it's all by magic, and I was a little more nervous to say it was by magic. But yeah, let's just, at this point, we trust them. All right? And so it meets their postcondition. Everybody good so far? All right, now you might say this is a funny instance to give our friend. It has nothing to do with our input. And of course, it was just an example to show you really can give your friend anything you want. Right? So what are we going to give our friend instead? What we're going to do is we're going to take our input and we're going to just cut it in half. Right? We could put a lot of effort into how to cut it in half, but we're not. We're just going to cut it in half. And so those are our two halves. And the first friend is going to be given the first half. Right? And what is our friend going to do with it? Sort it. How does he sort it? Magic. You guys really don't listen very well, do you? All right. So you'll note that it does meet the precondition. It is smaller. And so by magic, your friend gives you the sorted list that meets the postcondition. Right? Everybody good with that? And then, so there's that. We have that sorted. And then we have our second friend who we give the second half of our list. And that friend, it meets the precondition and is smaller. So that friend sorts it, right, by magic. And so now we have these two parts sorted. Right? Everybody good with this? And now what do we do with them? We merge them together. Exactly. So it's like traffic. Imagine you have two lines of traffic. You put our two lists down there. So they're ready to go. There are 2 lines of traffic ready to go. And you'll note that each list is sorted, right? So where is the biggest number? Right? It's the 98, and you can tell it's going to be the first on one of those 2 lists, right? Because each list is sorted, so the maximum is going to be on the top of one of those 2 lists. So you look at the top of the 2, you compare the top 2 and see which one's bigger, and the biggest one goes forward, right? And now, where's the next biggest? Again, it's going to be one of the top 2. So you compare, and you keep doing that. Does that make sense? Right? So we're just merging this traffic, and then that was good. So that's merge, and then that's our answer. Everybody get that? So the goal of recursion is that it's really easy, right? Right? You just, right? In some ways, it's so easy that people are uncomfortable with how could that work, right? Everybody good so far? All right, so we get our postcondition. Now, all right, so here's, I guess, this is just the code, right? And we have our precondition, we're given a list, our postcondition is sorted. My responsibility is to make sure that my algorithm works under the assumption that my friends do what they're supposed to do. All right? Remember, we're in the friends and strong induction way of thinking about it. And in this world, we have friends that we can trust, as long as you give them instances that are smaller that meet the precondition, right? So here, that's what my responsibility is, right? So here, how do we kind of go through it, right? We're considering our input, and there's our input, right? Here's the various variables that we might have. This blue box we're going to see, you've seen it before, is a stack frame, right? Here I'm doing my job. So here I'm given a list. That's my list. That's my input. And what do? I construct more, a couple of sub-instances. So I take the first half of my list, and I make it the left subinstance, and I take the second half of my list and make it my right subinstance, right? What do we know? Well, we know these lists are smaller, right? Why? Because it's only half of the list, right? And we know that these guys meet the precondition. Why? Because they're lists, right? What was the precondition? Is that it's a list, and look at, these are lists, right? And then, by magic, right, we recursively call on these 2 pieces, and by magic we assume that they give us the answer, right? And there's our friends. They do their work, right? And so they give us the answer. And then, oops, sorry, outside world, I dropped you. Hello? You've officially been dropped. All right, so now we're going to take our friends' answers to get our answer. And how do you do that? Those are our friends' answers. And here, that little picture, that's the merge thing. The merge thing gives us our answer. Right? That's just saying it again, the various things that you have to do when you design a recursive program. Everybody good? And don't worry about your friends' friends and your bosses and various things. Uh-huh. It's pseudocode. Is there something you don't like about it? I don't know. We'll get to Java later. The Java looks uglier, right? So we try to not bring in uglinesses when this is ugly enough. We'll introduce uglinesses one at a time. I mean, you can't write this in Java, right? I mean, but But you get the idea of it? I don't know. You just write things so that it looks like code and it's easier for somebody to read. All right, so here, now, the other thing that we haven't stated yet, there's this idea of a base case. And you're considering your input, but if your input is so small that you can't give a smaller input to your friend, then you have to solve it yourself. So here, if the input's only one number, then you just do it yourself, right? So here I'm just making the note that the code for the base case appears before the code for the general case. But just like when we were doing induction loop invariance, I like to focus on how to maintain the loop invariant before I focus on how to establish it. And you don't have to think about things in the order in which they're coded. So, all right. Now you might say, how is this an algorithm? And so, right. So I think I might have shown you these slides already. Did you guys see these ones? Right. Right. This is the example where the houses and so you'll note that I'm trying to get into the big house, and my friend's house is smaller and his house is smaller, and then you have the base case where you can just take the roof off, right? All right, and then you've seen this already, strong induction. What do we do in the strong induction? Strong induction, you're trying to prove, you have some statement, S of n, which is for every n is either true or not true, and you want to prove that S of n is true for every n. And the way you do it is you prove it's true for 0, and then for every I, your goal is to prove it's true for S of I, but in order to do that, you can assume that it's true for all smaller guys, right? And so how does that work here is our induction hypothesis, S of n, will be that the recursive algorithm works for every input of size n, right? Instead of proving it works for every input all at once, that gets to be scary. So we're going to just focus on inputs of size n, right? And so the base case is showing that it works on inputs that are sufficiently small, right? And the recursive step says, well, in order to prove it works on inputs of size I, I'm going to assume that it works on inputs of any size smaller than I, right? That's where we're assuming that it works on our friends, and then that'll give it that it works for us, right? Everybody buy that? That's why we're calling it friends and strong induction, because the friends is we're trusting our friends as long as we give them a smaller instance, and that's basically strong induction. Everybody good? And then so we get the algorithm works for every input of every size. Years ago I made this example for you guys, which was just too ugly, but I couldn't throw them all the way. So I kept just this one here, and you can go through and see that this code, in fact, gives you multiplication. But, yeah. All right, so one thing that's important, in general, it's important to have a well-defined precondition and postcondition of your problem, right? But when you're doing recursion, it's particularly important. And the reason is because you need to know the preconditions so that you can know what inputs might be given you, what you might be given, and to make sure that you solve all of them. But similarly, you have to know what instances you can legally give your friends, right? And similarly, you need to know what postcondition is expected of you, and you need and you also, it lets you know what you can expect from your friends. Right? Does that make sense? Now sometimes, and we're not going to get into this so much in this course, but in 30-101 we'll find, well actually even in this example we're doing now, we're going to say, oh, we want more from our friends than our pre and post condition specify. So we want to change what we get from our friends. We want a wider range of things from our friends, and that's okay. You can change the pre and post conditions so you get more things from your friends. But then, if you do so, you have to, one, show that you've changed it, and two, make sure that you and all your friends are using the same in pre and post conditions. Right? If your friends do it, you have to do it too.